What we're making are long bed, wide bed, vertical machining centers. The bottom line, they're custom bed machining centers for an affordable price to give shops an option to get into a big machining center to do big parts so they don't have to buy $1 million bridge mill or something that's just completely out of their budget. We're changing CNC machining with our capabilities and design. So if you need it, give us a call. We can build it and make it suit your needs. Hey, Nick Kennedy, FlexCNC. Hey, today we're doing a time analysis for a customer doing some dynamic machining in a block of aluminum. So what we did, we went and reached out to Kennametal to source a really nice end mill so we could really get our machine times down. And to explain this end mill a little bit, this is a 3/4 inch Kennametal Maxi Met. With this guy, we were able to take a 3/4 inch depth of cut, a 225 thou width of cut, and feed it around 90 inches a minute at 4,000 RPM on the FlexCNC. What we're gonna show you is how using this tool versus your traditional 3/4 inch end mill, we're able to take our time from 10 minutes and 30 seconds down to 1 minute and 50 seconds. So using the Delta controller on the FlexCNC and high-speed tools, we're able to take a part like this and whittle it down in about 1 minute and 50 seconds. It's an awesome time analysis. The FlexCNC gives us a ton of machine bed to work with, and we'll be able to show you all those details and how setting up parts like this, we can set them up in stations seconds, and literally every minute, 50 seconds, make a part like this, nonstop. Using smart programming, great tools. Give us a call, 800-837-2503. Let us do a time analysis for you and show you what we're able to do with that FlexCNC and how we can help you make more money on your next job. Hey, today we're going to show you a pretty cool application, 20-foot long piece of tubing, set it up on the CNC, one op. We're going to go through the top side of the part with the drill in this case, wrap it through, and then drill through the bottom. No flipping of the part, just setting up on the machine once, hitting cycle start, super fast. Again, nothing's going to be faster to process a job like this. You can see how long these things are, how heavy they are, how difficult they are going to be to set up on any other machine. What we're going to be running is inch and 13/16 drill. About a little over 12 inches long because we have to go through both sides of the tube. Again, so we can do this all in one op. We don't have to flip the part. We don't have to do multiple ops. We're going to set up on the bed and do it all in one setup. We're going to hear a little bit of some squawking just because it's such a long drill, but it's the only thing we can use to get it all the way through the part in one setup. So that's it, running the 20-foot long tube. Got 9 holes, takes us about 9 minutes and 25 seconds. So I mean, that's super fast for such a big part, such a big hole, especially to go all the way through. Again, no better machine to run that on other than the FlexCNC, G-Series, big gantry. Give us a call, 800-837-2503, and let us do a time analysis for you and show you how you can save a ton of machine time using the FlexCNC big bed gantry.
We got the 2 different allied drills here today that we'll be testing out. One is the Gen 3, the other one is the Vortex. They're both the same diameter, with different speeds and feeds, going through the same material, going to the same depth.
What's up, everybody? This is Eddie from FlexArm and FlexCNC, and we are coming at you live from our beautiful facility right here in Wapak, Ohio. We have an amazing demonstration for you today with some of our good friends at Kyocera. We're actually going to be doing some high feed milling and chamfering on some really cool parts, and we're really excited to show you. But before we get started, just a couple of housekeeping items. You'll notice on this side of your screen there is a chat box, and we highly encourage right over here for you to enter in any comments, questions that you may have, because you never know. We could be pulling up your comment or question and answering it in real time. And we also have associates in the chat that'll be happy to answer any of your questions as they come up. So we thank you for your participation. Also, on this part of the screen, you're going to notice there's a subscribe button. Please hit that bad boy, hit the bell so we can keep you up with all the amazing notifications and videos that we have, and give us what my daughters would say is a huge thumbs up. We would greatly appreciate it. Look, Diana already given us a thumbs up. That's a great start. So that being said, let me introduce our great friends coming at us from Kyocera, my man, Matt and Todd. How you guys doing today?
Doing good, doing good. Thanks for having us.
Yep, doing good.
Always a pleasure. I know, Matt, you're a veteran of these things, so Todd, thank you so much for joining us. So I'm curious, for those in the audience who aren't familiar with you, what do both of you do at Kyocera?
My function at Kyocera, I'm the indexable side for the technical center, the engineering manager for that department out of North Carolina.
Awesome, awesome.
And I'm a design engineer at our Wapakoneta facility, designing standard and special steel bodies.
There we go. We got some true experts on the stream today, so we appreciate you guys joining us. And though Kyocera is a very well-known brand, I'm curious, what makes Kyocera cutting tools so special?
Well, Kyocera is it's a very old company. It's been established for many, many years. It's very globally diversified. We're throughout the entire world. The thing I like about Kyocera, I've been a member of Kyocera for 30 years. This past October, started right after college, and the majority of our employees have longevity. We're not a company that has a lot of turnover. We have people that stay for a long time because it is a very philosophy-driven company. Okay, it's very employee focused. The management is very focused on taking care of its employees because, you know, that's the backbone of any company. If you know our company motto, it's respect the divine and love people. So that describes kind of in a nutshell what Kyocera is all about.
No, that's awesome. You're truly passionate about what you do, Todd, and that's exactly why we have you with us here today. So thank you, gentlemen, for giving us a little bit of background on yourselves. But I know you're not here to listen to me talk, man. Let's get the demo started. So what we're going to do is we're going to be heading over here. We have our G-Series 2004 with a high output package. And what we're going to do is just some milling and chamfering on some small hex block here. And we're going to be able to demonstrate the high quantity machining capabilities of the FlexCNC. So Aaron, you're the expert, man. Tell us about what's going to go down.
Yeah, so those of you who have joined our videos before, you've probably seen this part before. This is our standard hex block, but instead of using the drills and the end mills that we have previously used, we're going to use Kyocera's high feed mills. We're going to go around the outside here with the 2-inch MFH cutter, and I'll let both of these guys talk about them. But the center bore here we're going to knock out real quick with a 3/4 inch indexable end mill, and then the slots we're going to knock out with a 1/2 inch. So I'm going to get the program started, and the first tool it's going to run is that 2-inch, and we're going to run it at 1146 RPM at 366 inches per minute. So guys, as this starts the machining process here, if you guys want to just go ahead and talk about this MFH cutter real quick.
Chuck's experience. But anyway, MFH is a very unique cutter. I don't know what's processing right now, but the thing about the MFH, it's all about metal removal. Okay, it's not about finish. It's not about anything but metal removal. It's made to be light depth of cut, high feed. Okay, so 300, 400 inches per minute. It's no problem, especially in carbon steel or any kind of steel. The thing about the cutter that makes it also unique is it can perform any three-dimensional application you need, ramping, helical, as well as facing, slotting, it can plunge. So it's a very versatile cutter and a very great addition to our Kyocera milling arsenal.
The cutter that's running right now, MFH 2000R038T. So that is an 8-flute, 2-inch diameter high feed cutter that's being utilized right now.
You talk a quick second about just maybe a little bit of the noise that we're hearing here.
Yeah, so I did forget to mention kind of how I programmed this. Like they said, you want a low depth of cut, high feed rate. So I'm ramping around the profile of this part, only going 20 thousandths deep per pass, and so the reason why I had to take 2 swipes at it, it was going to leave a little bit of an island there in the corner. So that's what that first pass was doing. It was going around the far outside of the block. And here now we're roughing out the hex. Still going 20 thousandths depth of cut, ramping down the profile of the part there.
So while we're putting, some work in here on the FlexCNC on this specific part, can one of you gentlemen speak to this specific tool and what other applications this may really excel in?
Like I said, the screen. What are we running in right now? The 2-inch?
Yes.
Yeah, so the 2-inch is basically, like Matt pointed out, the great thing about the 2-inch cutter is we allow 8 flutes per the diameter, right? So that's massive metal removal. I think you pointed out we were at 366 or more inches per minute right here. The great thing about the 2-inch is it's also very compatible to small horsepower machines like Cat 40s and things like that. It's a very good, useful tool for even the lower horsepower machines as well, because you get so many flutes, but because of the very effective chip thinning technique and the light depth of cut that the MFH provides, it makes a perfect addition to the smaller taper machines.
Looks like we actually have a question, gentlemen. So my man, Fred Freeman, thank you so much for joining us. So he says, what's the MRR for the 2-inch cutter? Would one of you gentlemen like to tackle that question for us?
Well, without
we'd have to make
calculator.
Yeah, we'd have to make some calculations to get the metal removal rate, but it is running a 20 thousandths depth of cut, and it was running 366 inches per minute. So we'd have to sit down and see what the width of cut was, that type of thing, to figure out the metal removal rate.
Yeah, and the metal removal, again, is something you calculate based on the material, because, today we're running 1018. You get in Inco or you get in titanium, pH stainless, something like that, a metal removal is going to drastically, change based on your application. We can calculate what we're running today when we get a moment. I just don't have that right this second on hand. I'm sorry.
No, you're great, man. Fred is one of our good friends. He asked some amazing questions. He has a great background himself. But with that, while we're setting up, you saw there was a tool change. If you are in this live stream right now, put in that comment section where you're joining us from. We'd love to know where you're coming in at. And then, stuff going on here. Tell us a little bit about what we're seeing.
Yeah, so here we're ramping down through the slot with the 1/2-inch micro cutter. And you guys can talk about it here in just a second, but same thing, we're going 20 thousandths on my ramp here. We're going 3,950 RPM, at 133 inches per minute. And I apologize, you guys were talking while I let that 3/4 inch cutter run, but I did the same thing. I just ran a helix bore pass on the center of that bore there, 20 thou depth of cut on the helix, and it was 3,000 RPM at 366 inches per minute.
With this cutter we're running right now, it's the MFH 0500. So it's a 1/2 inch diameter, and it is a 3-flute cutter. So it uses our LOGU 01. So even though it's only a 1/2 inch diameter, it is still a 3-flute induxible cutter. So
yeah, the reason we brought in, we went down to the micro lineup for the MFH cutters is primarily to go after the solid carbide market, because if you can get a high-feed cutter with 3 flutes, you can do some pretty decent damage on slots and things that you just saw. The thing I will mention about this micro tool that you just saw, the 1/2 inch, because we do put it on such a small diameter, 3/8 we even go down to for this cutter, up to 5/8, it is a positive insert. Okay, so you cannot flip it over and get 4 cutting edges out of the micro. All the other MFH lineup that we offer will be 4 cutting edges, except for the micro, just so you know.
Okay. Well, no, that's solid information. And if we did not clarify, I want everyone to know we are actually working in steel. So let's say, gentlemen, for example, if this was maybe a different material, maybe in aluminum, how would that affect the type of tool that you use?
Talking a little bit different, because aluminum is something that this tool can do, but it's a molded insert, right? So it's not really made for the aluminum market. However, with that being said, we do have good success with using the ones we're using today, as long as it's the mini, the MFH mini, the LOGU, as you can now tell, it's a ground insert periphery. I can run in aluminum, okay, and still not adhere to the insert. If it's a molded insert in aluminum, it's not usually a good combo, because you'll get some built-up edge and adherence from the material onto the carbide, right? So, but with the LOGU or the LOGT that we just saw in the micro, you can process aluminum effectively with this cutter.
Okay, right on, right on. Aaron, you want to pop that bad boy out and we'll put that up on the 1080? Man, looks nice, looks nice. All right, good deal.
Once again, you guys were talking there, and so another tool that we use that is your guys' tool is the chamfer mill that has 2 inserts on it. If you guys want to touch real quick on that, there we go.
yeah, the chamfer mill that was used on this hex block, it was the CM 0563 4509. So it's a 45-degree lead, 9/16 root diameter chamfer tool. So that's what applied the chamfer to the bore, the hex, and the slots there. So, and we have the chamfer mills in 2 different size ranges: the 1-inch root diameter and the smaller 9/16 root diameter. And then we have angles from 3 degrees up through 75 degrees. Once you're above the 3, we go every 5 degrees.
Well, right on. Looks like we have another question. Fred, thanks for chiming in again. So he was curious, what's the max length on the 3/8 micro?
The max overall length or the max depth of cut? The max overall length on the 3/8 micro. Give me just 1 second and I'll give you that info.
There we go. Fred's a curious guy, so we like to feed him.
Hey, I like it, Fred. Keep them coming, man.
There we go, there we go. We can always count on good questions from good old Fred. And feel free, while we're getting things set up here, if anyone else who's joining us from the stream, it is completely interactive and open to anybody who is present. So again, feel free to, oh look, so we have something. Ron Dormer, look at that. Do you not use air for chip removal?
Yeah, so that was actually something that I wanted to mention. What I didn't do was put the air in there, and as you could watch, as those tools were, I'm muted. How about now? Are we good?
There we go.
Gotta love live. Okay, so as I was saying, yeah, no, I did not put the air blast in there. And yes, that is something that you would want to do, and you'll see another instance in this next part that we're going to run, that the air blast, as far as especially your tool life, would help you out. The only reason I don't have it was just, you know, we wanted to make sure that we were able to see everything. And but yes, if you guys want to touch base on that a little bit more. And another thing I know people have kind of different thoughts on is coolant also. You know, is coolant a suggested thing to use on these inserts, or no?
Yeah, we get this question a lot. By the way, Fred, the answer to your question is overall length for the 1/2 inch micro is 1.4 inches. Did you hear me? Hello?
Let me chime back in.
Can you hear me?
Mm-hmm.
Yeah, we can hear you.
Yeah, we're good.
Are you good?
Yeah, I was answering Fred's question first. The overall length of the 3/8 he wants to know about the 3/8 micro. I thought he was asking about the one we were running.
He's on
the 3/8. To be honest with you, the 3/8 micro, Fred, I know I mentioned we go down to a 3/8. It only comes with one flute effective. So to be honest with you, I probably would move on to the 1/2 inch or the 5/8. The 3/8, I'm not sure about the overall length of that. I know we have a 8 millimeter, which would be comparable. So it's probably going to be about a 31.5 millimeter overall length. The one we're running right now is 1.24 inches. The answer to the other question, as far as the coolant and air, we get this a lot. Air is always good. Air you can always use, no problem, okay? It helps evacuate chips especially when you're doing ramping or pocketing and things like that. In steels, you do not want to run coolant. You want to run dry. Too much thermal shock effect comes into play. You're heating and cooling that insert way too much. And so for steels, you want to run dry. Now, when you get into your stainlesses, pH stainlesses, of course your high temp alloys and things like that, you definitely want to run coolant, okay? Preferably through the spindle coolant, because every Raptor we sell, every MFH cutter we sell has through the spindle coolant capability, so we can project coolant at each pocket, okay? But for steel, no. Stainlesses and above, I would say yes. As far as air blast, you can never go wrong, okay?
There you go. No,
what I'm
solid
showing you
answer,
guys,
man, for sure.
Sorry,
for sure.
Eddie.
No, you're good.
So what I'm showing you guys here is going to be the next part that we're going to run. The two tools that we're going to use on this is that 2-inch MFH cutter again, and the chamfer mill. Now, if you can see, Isaac, there we go. These little scallops right here. This is just going to show you the versatility of this tool right here. You'll see it here in a second when I get the demo going, but I'm just going to run a drill cycle, and we're going to plunge into this material to create these scallops. Now, I don't know if I missed anything earlier, but you know, just to kind of speak on more of the versatility of this cutter, is that something that you guys want to touch on real quick, and I'll get this started.
Yeah, like I mentioned.
Go ahead, Todd.
Like I mentioned before, this is probably one of the most versatile cutters we have because of the fact that you can pocket, you can slot, you can ramp, you can, like we're doing right now, a plunge. And the beauty about this cutter is just the fact of, if you have a lot of material to remove, you want to use a high feed cutter, okay? if you use a high-feed cutter, you're not going for finish, as you can see. You're not going for anything except metal removal. You're going to have to come in and do a process after you use one of these high-feed cutters because it's not made for that. But there's no other cutter out there. A 90 degree, yeah, it can plunge. A 90 degree can do a sidewall. A 90 degree can face, but it can't ramp because it's a negative tool, right? It can't pocket effectively. So the versatility of this comes from the fact that the design of this insert allows it to do any three-dimensional programming move you want to do.
Looks like we got a question from my man, Patrick McDowell. Patrick, it's awesome to have you on one of our streams, finally, man. He says, are your suggested speed and feeds based on certain tool life in minutes or distance? Thanks for your question, Patrick.
We get a lot too, and it's a very difficult question to answer. Normally, especially whenever we're told all these recommendations for speeds and feeds are meant for 20 minutes time in cut, okay? Now, I can tell you right now, I've ran an MFH in material such as this for over an hour, nonstop. You see what I'm saying? So it's very difficult because it depends on your speed, your machine. It depends on the horsepower of your machine. It depends on the taper you're using. It depends on your fixturing, things like that. It definitely depends on material. I'm not going to run for an hour in Inco like I am in 1018, okay? 304, I can run substantially long periods of times as well. But it's very difficult for me to sit here and accurately tell you whether it's length of cut or time in cut. Basically, we just need to look at the chips and look at the wear pattern on the insert is the best way to come up with that situation in your particular shop.
No, that's great. Isaac, do we have any other questions in the queue while we got this process running? No worries, man. So with that being said, while it's going, guys, I'm kind of curious, what are some other top tools that you have over there at Kyocera?
Where do I start? Geez. Other than upper management such as myself, that's probably the top tool. I'm just kidding. We continuously strive to come out with new tools, okay? New grades, new tools, new coatings. That's one of the things that we really shine at. Milling is one of my favorites with Kyocera. We're introducing now new tangential mounted milling cutters, our MEVs. We have a very good 45 degree face mill, MFPN. If you really want to do some massive metal removal at a slower pace, we have our MSR, our monster cutters, and what that means is they have the chip splitters built in, so they break the chips into smaller pieces, but I mean, you can go 1.5 inches deep per pass, 1.5 inches wide per pass if your machine can handle it. We have so many versatile cutters that I would say that, probably you would just have to get into our catalog and look. I know our grades, we're coming out with a PR 1535 is probably the toughest grade we offer, very versatile. Anything from steels, pH stainlesses to titaniums. We just offered a new MEAS cutter. That's for aluminum, very high ramping capabilities. PR015S is another grade we came out with for hard milling now for Rockwell hardnesses up to 55 Rockwell and so. We're very competitive when it comes to all of our milling products out there.
Well, awesome. I know, very loaded question, and I'm sure it's probably hard to say all of them, but Matt, were you getting ready to say something, man?
We're really known for also is our cement inserts. You know, that's a huge thing in turning, and even in the milling. The chamfer mill that you're running right now has Cermet inserts in it, which is a pretty unusual thing in a milling operation. So, but yeah, Kyocera is really known for our Cermet grade style inserts.
Very nice, very nice. Looks like we're getting kind of close towards the end of this, so another question I have is, I want you guys to be a little biased. I want you to play favorites. Each of you, what's your favorite tool that Kyocera offers?
For me, it's the one we're running right now. I love the MFH. It's so versatile, and what I love about the MFH is if you're processing, which we see more and more nowadays, of high temp alloys, from pH stainlesses to Incos to titaniums, these cutters are made to perform in those materials. And so this has got to be up till this point until something else comes along that I love.
A little bit of B-roll there, looking pretty solid. Oh, Patrick, my man, got another one. I love it, I love it. So when measuring wear on edge of insert visually, what do you recommend as a stop and index point? Patrick, you're killing it today, my man.
I finally get to see what Patrick looks like. He looks a lot like me. Yeah, Patrick, normally what we tend to strive for is about 8 thousandths of an inch nose wear on the insert, blank wear on the insert. Once we exceed 8 thousandths, then we basically want to flip the insert. Now, with that being said, if you're not experiencing microchipping or you're seeing some thermal cracking or anything like that, you can push it a little bit farther. But normally, I would say we want to stop at about 8 thousandths of an inch wear on the edge before flipping the insert.
There we go. How's it look, Aaron?
Pretty good, a little warm, but I got some sissy hands, so I'll just grab a rag.
Oh, you didn't see me run towards it, yeah.
So here,
yeah, be careful. That's going to have a little bit of heat to it.
Yeah, it's a little warm. There you can see it right there.
Wow.
The scallops, the chamfer mill, and to kind of go back and answer Eddie's question that he just asked you guys, you know, the MFH cutter was really fun to run, but I'll tell you what, these chamfer mills really put on a nice finish. I can take a fairly deep depth of cut with it to put that chamfer on there. I've been really impressed with these chamfer mills.
Looks like Daniel, look at that. All right. So Daniel asked, which are advantages of MFH line against OSG Phoenix line? Interesting question, Daniel.
Good question. OSG Phoenix, Matt, you familiar?
I am not familiar with their Phoenix line, so I guess, you know, biggest difference is ours is indexable. You know, I'm going to say from OSG that's going to be a solid carbide, so, you know, probably at least cost savings there. You can index inserts instead of having to replace the entire cutter.
There we go. Now
what
the homework to do.
One other thing to mention about get that question, you know, what makes yours better than the other guy? And even if we're talking about indexable, our insert design is very unique. Okay, our insert design is made to be able to outperform the competitors when it comes to high feed milling because of our unique cutting edge. We have this convex cutting edge to our inserts, to every MFH insert. And what that does, it enables our insert to glide into the cut gradually. The competitors' inserts are flat. They don't have that nice convex edge to it to allow them to ease into the cut. They smack into the cut full front every time they make contact. By allowing us to do that, we can push higher feed rates, we can have better chips, and we can also enter and exit the cut with a lot less vibration. And you can see that now that you're holding that up. If you'll point to the top of the index to the top of the insert there, Nick, you can kind of point out where I'm talking about. See how it kind of ridges up on the end right there? That's the difference between our design and most of the competitors.
And there's that, this is the 2-inch that we were talking about earlier. Yeah, 8 inserts on it. And I mean, you saw the finish on that last part there. Even though this is a roughing tool, the finish really came out really good. Now, something else I'll mention on this hex block that we did. And like I said before, this is like one of our standard demos that we run in some of our previous live streams that we have done. And the total cycle time with the tooling that we used previously, it was about 9 minutes. And I had this part entirely roughed out in about 4 minutes. So, you know, the only thing I need to do now is come in and take a finish pass, and it really cut down on my cycle time. I was taking a lot less depth of cut, but like you guys have been talking about, you know, I can really ramp up that feed rate and really go to town with it.
Yeah, one thing I'll mention too, the other line of the other family of the MFH is the square inserts. Okay, so it's an SOMT insert, let's say. The SOMT is different than the ones we're running today, which is more of a rectangular based insert, right? You still get 4 cutting edges out of that one, but the square insert you do as well. But the SOMTs we actually offer 4 different chip breakers. So we got one for general purpose. We got one that's sharper. Then we got a AD chip breaker that allows you to do a heavier depth of cut, lower feed rate, and then drop back to your lower depth of cut and keep moving at the high feed rates. And now we got the new GH chip breaker, which is basically for hardened materials as well. So with the square inserts, you can actually get a little bit more, I guess, choices in what chip breaker you want to do if you do want to chase some kind of particular finish.
Oh man, so hey, so we pulled a couple of chips here, and these are just a beautiful, beautiful blue. You want to tell us a little bit about why that is the way it is?
Yeah, the blue means we're getting the heat out of the chip, which is what you want. You don't want your insert to drag or not cut sharp enough. You want a nice heat generated in that chip, so it's not getting generated into the workpiece. You do not want to work harden your insert, your workpiece as you move across the part. Very important, especially when you get up into the higher temp materials, not to heat treat that material as you're going. So you want a nice blue chip as you go. That means you got really good heat dissipation. Yeah.
It looks real good, guys. Love it, love it, love it. All right, let me get these bad boys off my hands without getting them all stuck in there. All right, here we go. Good deal. So with that, hey, that's really the demo we have. I want to make sure, are there any other questions in that live stream we need to address? Awesome. Well, hey, we thank each and every one of you for being interactive, for engaging with us. It helps us provide the best live stream experience for each and every one of you. So with that, I want to thank my man Matt and Todd. Guys, it's been so great having you on our stream. Hopefully you had just as good of an experience as we did.
Yeah, it was good.
Yeah, it was. Thanks, Nick. Thanks, Eddie.
Yeah, and absolutely. And then lastly, so if people want to learn more about Kyocera cutting tools, how do we get that information?
Oh, that's easy. Call our 1-800 number if you'd like to. You can always get the tech center. That's 1-800-823-7284. You can either get customer service or technical support by choosing the correct option, or you can always just go to our website at mykpt.kyocera.com.
Right on, right on. Well, you gentlemen are both true, passionate experts, and we appreciate you as well as everyone else who has joined us for this demonstration. Please make sure before you go, hit that subscribe button, hit the notification so we can keep you in the loop with all the amazing videos, and give us a huge thumbs up. But until next time, you all stay awesome, stay flexing, and we will see you next time.